All right, so we're going to take a look at a lesson on how to expand logarithms. Expanding is very similar to condensing, except for it's in reverse. So basically, you need to remember the rule that if you multiply within a logarithm, then that means you are going to add those logarithms of the same base. Okay, so that's an important concept that comes again from the exponentials that we've already learned. So it just means I have the same base, but now I'm going to basically bring it on the outside and make that externally an addition. So basically, what I would always tell you to do is if you don't see how this one has a parentheses, is I would always put the parentheses in, and then I would try to determine where the multiplication is happening. For instance, right here, it's happening right there. So this is a log base 10. So I'm going to write log base 10 down twice with a plus sign. Why am I writing it down twice? Because there are two items inside here. Then you have log base 2 times x, so the expansion will be to put a plus sign. All right. Here again, this one's already has a parentheses on it, so you would multiply three things. So you're going to write the ln, which is of course log base e. You're going to write it 3 times. And as you get better, you can go ahead and do it all at once. But the reason I tell you to do it 3 times is so you know ahead of time what to fill in and how many items you have in general within that logarithm. So we get to a problem like this, and these are very algebra 2-ish if you learned it in algebra 2. But now that we're doing algebra 3, the question is, how is this subtraction problem possibly a multiplication problem? And the key here is, of course, the fact that we have a square, and squared things, as you might remember, usually need to be factored. So factors of 7, pretty easy. You have 1 times 7. And since you have a subtraction sign right here, you need to subtract these, and the goal is to get -6. It's pretty easy to do mentally because you only have 2 numbers. So I'm just going to rewrite this in factored form. That would be, right, you have x plus 1 and then x minus 7. Now, there are many ways to factor. However, when you have a lead coefficient of 1, you can simply add or subtract to get the middle term. This one's asking you to subtract these. That's why I have plus 1 minus 7. And keep in mind, when I do that, that the x's come from, if you were to multiply back out, the 1 times the x and the 7 times the x would subtract together to give you -6. The key in this problem is that there's a multiplication sign here. So in the world of logarithms, I'm going to write log base 4 down twice with parentheses. And then I'm going to fill those parentheses in with what is inside of here. So x plus 1 and then x minus 7. All right, not so bad. All right, let's take a look at the next one. Okay, the next one is the quotient property. And again, if you've already seen the video on condensing, it's the same rule, but we're going in reverse. I mean, these are the answers that we had in the previous lesson. So if you have division, then what you're going to do is you're going to subtract. So we're going to take log base b of m. The numerator is always on the left, and then minus log base b of n. Now, this hopefully makes a lot of sense from all the exponential stuff that we've talked about. Negative things go on the denominator. So this is on the denominator, so it'll be a negative thing. It's the same idea. So here we have log base 3. There are 2 things, and this is a little more clear, honestly, than multiplication, right? Especially when you get to something like that. Very clear that there are 2 things. So you have the numerator on the left side, and then you subtract the denominator on the right side. Now, I will show you something that's interesting. This is the correct answer. However, you might remember the whole what is the exponent that will make this answer. So this is technically 0. So this answer would reduce to this, which is an important thing to understand about. Sometimes when you expand, logarithms will actually evaluate, meaning 3 to the 0 power equals 1. So that actually goes to 0. Now, when you look up here, the reason I didn't do it up here is none of these actually have that happening. But since I saw that, I thought I would mention that sometimes they reduce. For instance, if this was a 9 right here, I would want to put a 2 because 3 squared would be 9. So just keep that in mind as you do it. Sometimes students will be like, where's my answer? And it's because part of it reduced. Okay, so here we have ln of the numerator and then minus ln of the denominator. Nothing reduced here because none of these are e-based numbers. Here we have log base 2 of x minus 7 and then minus log base 2 of x plus 1. Very similar to our problem up here. but this one we had to factor, and this one we didn't have to factor because if you have a numerator denominator, they're not together to factor. So again, I feel like quotient sometimes can be easier. It's very easy to see what they delineate. Again, if you want to know what happened here, this turned into 0, and so if it's 0, we just don't write it down. So that technically would be the simplified answer. Okay, so last one we're going to do is the power rule, and you might remember that the power rule is to multiply. And so this one, for some reason, is the easiest rule when you're done with it, but for some reason, it's hard for kids to sometimes see it. This basically will just go on the front to become multiplication. So it'll become n times log base b of m. Okay, so a lot of times it helps if we just go, boop, there's the answer. It just goes in the front. So x log 2 of 5. And again, if you want to put the multiplication sign there because it makes you feel better, because that's what the property is saying, then please do. So then we get to something like this, and the question is, well, how could this possibly be right? And the reason is because if you remember what you did with roots and exponentials, this is really to the 1/3 power. It's really important in the world of logarithms and exponentials to realize that all roots are really just exponents. So that third root is now going to be in the front. And then you have ln 2x plus 1. Okay, again, if you want to put the multiplication sign there, no problem. So this one can actually be done two ways, right? You could do it the division way, very similar to this question. But the idea here in this problem is, log 1/64 could be written as, and we could write it really interesting, right? Remember, this could be written as 64 to the -1. If I want to break it down even more, it's really 8 squared, but because it's a fraction, it's negative, okay? And so then we're going to move this to the front. And the reason that's such an important thing to understand is simplifying logarithms can be a little bit subjective, but this is the simplest form of this. There's not two expressions. This also explains up here, like, why did this disappear? Because if I did it with the division way, it would have gone away anyway. Notice that this answer only has one answer. And notice doing it this way, I only have one answer. So doing it this way just goes directly to the answer, as opposed to here, it takes 2 steps. All right, the next video, we're going to look at some examples. Hope this was good. And let me know if you have any questions.